Hey everyone, I'm Sam. This is Raph over here. We're going to give a presentation about yes or, the introduction to domain modeling with types. And we want to make sure that everyone feels safe here. And no matter what your job title is, you're going to feel comfortable with domains after this talk. It's something that we talk about a lot while we're replatforming. And so we want to make sure that everyone is on the same page and everyone understands the power of or and when we're talking about domains. They're two very small words, but they mean a lot when we talk about domains. And no one said it better than Chef Gusteau himself. Anyone can model a domain. This is a quote, of course, from my favorite Pixar film, the 2007 Ratatouille. And I think he was onto something when he said this. And in that vein, we're gonna take inspiration from that quote, and we're gonna cook our own ratatouille, but we're gonna do it as a domain. And so that way you can understand a little more about what we mean when we talk about domain modeling. So let's say our domain is cooking ratatouille. How do we model cooking ratatouille in code? Now, this is kind of a peculiar thing, but stick along for this analogy, and I think it'll start to make sense. So we need two things to begin modeling. We need the data and the behavior. And once we understand those two things, then we can write our code to reflect that. And with this equation that we have here, an example of the data would be the ingredients of ratatouille, the summer squash, the tomatoes, all the other things. And the behavior is going to be cooking the ratatouille, whether it's the time amount or the temperature of the oven. That's what we're thinking about when we talk about data and behavior. But we have to be careful not to, we need to be very specific about what we allow as data and what we allow as behavior. Otherwise, we can get some pretty wonky ingredients or maybe some interesting cooking options that don't make sense for this dish. And that would just lead to bad code. And this is what we have to be careful about when we're modeling domains. This happens, even though this is a really silly example, this happens all the time in code. And so in this example, there are a lot of other dishes, if we don't specify our data and behavior correctly in code, there are a lot of other dishes that would be output by this code other than ratatouille. So how do we fix this? Well, there's three things we're going to talk about today. We're going to go over what a type is, how that's going to help us. Then we're going to talk about solidifying our domain. Ralph's going to go into code a little bit and give us some examples about how we can harden our code with TypeScript. And then we're going to talk about the glue of all this, which is communication. Ultimately, that's what we're doing here. We're a team, and everybody needs to know about the domain as we move forward and evolve our code in our domain. So what is a type? We're going to enter into my favorite segment of this talk. What type is this? Get out your pens and papers, and you can write down your answers and send them over to us, and we'll make sure that you get the right answers. So I'm going to show you a picture. You're going to have to guess what it is. What type is this? Okay. What about this? This one's a little trickier. Okay, good. What about both of these together? Also good. Types are natural. It's something that's just ingrained in us as human beings. We've gotten really good at identifying and categorizing things, coming up with taxonomies for things, whether it's something that's good to eat, something that's bad to eat, whether it's even behavior, whether it's good behavior or bad behavior. It's something that we just intrinsically categorize. And so thinking about that a little more, we can get a little more of a complex example here, which is, what type is this? If we add this to our group of vegetables, are they still vegetables? Is it a fruit now? You know, there's any number of things this can be. And this is where our domain experts, our friends here, they're going to understand the business. They're going to understand the domain boundaries that we set for ourselves. Because if we don't set boundaries, then we're just talking about the whole entire universe. And we have to model the whole universe before we model our ratatouille. And so it's really important to have these boundaries. And it's really important to have these domain experts. And there doesn't need to be a title associated with domain experts. It can be an engineer on the team who's been there a while. It could be a PM or an EM or anybody, really. In our case, it's Remy, our friend Remy. He's going to understand the domain the best here. And since we're in this culinary world, we're going to consider these vegetables. And so to dive in a little deeper, types are sets of values. When you go to the grocery store and pick up a carrot, that's just one carrot that exists within the set of carrots. If we think about the type carrot, we can think about some properties. Maybe color is one, length is another. There's all sorts of properties that define a carrot. But that's the important thing. And we can have some other examples here of basic types that I want to go over that we use in code every single day. These are called scalar types, but I don't want to scare you off with that terminology. So we'll just call them basic types. The first thing is going to look pretty familiar. This is what's called a string. And this is an infinite set of any sequence of characters. These are just a few as an example. And the same thing with numbers. It's an infinite set of all numbers. If you can imagine a number, it's going to exist inside this set. The only interesting one we have here is the Boolean, which is a finite set. It's a little different than the other two because it can only be true or false. But with these three types, that's going to help us build and evolve and have way more complex types. And Ralph will show you how using these is great, but can get us into some difficult situations that we'll have to build and make safeguards around so that we don't make huge mistakes. So I'll hand things over to Ralph. He's going to talk more about solidifying our domain.
Thanks, Sam, so much for the wonderful introduction on domain modeling and types. And thank you all for being here watching this recording. This topic of solidifying our domain in code is really close to my heart because it was a total game changer for me. And I'm really excited to share this with you all. So for those of you that don't know Sam, he's really good at asking this question, why are we doing this? Like, what's the point of what we're doing? And so to answer the question, let's go put on a couple different hats. Right? Let's start with a product management hat or engineering manager hat. Right? Let's put on one of these hats. So as a product manager or a engineering manager, we know that the reality is that things change. Right? Engineers come and go. Domains change over time. Wouldn't it be great if the domain lived in code, was up to date, and engineers could easily learn the domain from the code when needed? Let's go put on our engineer hat for a moment. Well, it looks like my hat over here. I'm an engineer. Wouldn't it be nice if we could free our minds from all of those domain details and get reminded of those details whenever we need them? And as a designer, wouldn't it be nice if engineers were better at collaborating with us to understand the domain over time because they're really incentivized to learn the domain? So this is what solidifying our domain in code gets us. So we're going to take a step into a different domain, payments. It's kind of like cooking ratatouille, but a little bit different. So in our payments domain, we'll focus on two different pieces, two different parts. One, a payment has an amount, and two, a payment has one of three different payment methods: cash, or credit card, or PayPal. And we can see our type definition on the right, where we have a type payment with 4 different fields: amount, cash, credit card, and PayPal. And we can see this question mark over here means that these 2 fields, credit card and PayPal, are optional, which means that if these didn't exist in this object, it's totally fine. So let's see a value of this type payment where we have amount 42 and cash is true. This looks reasonable. It makes sense. This is a cash payment. Fantastic. So let's play another game called Is This Valid? So let's look at a similar payment where we have the cash field as false. Well, is that a cash payment? Well, what other payment method is it? And look at this one over here. Cash is true, but we also have this PayPal information over here. And then what about this with all 3? Well, something's clearly wrong here. But despite that, these are actually all valid. And the reason they're all valid is because they can be represented in the code. And when they can be represented in the code, they make understanding the domain from the code harder. So what can we do to make it impossible to represent this hopefully invalid data in our code to make it more understandable? Well, to do that, let's dive into a definition called domain invariant. A domain invariant is something that doesn't vary in the domain. That's why it's called a domain invariant. Invariant means it doesn't vary and it's in the domain. Fantastic. An example in a ratatouille world would be having an assortment of vegetables where we have the eggplant, zucchini, summer squash, tomato, eggplant, zucchini, summer squash, tomato, repeated all the way in these circles, right? And if we didn't do that, well then, is it ratatouille? Or is it maybe a cooked salad, right? So this is what we mean by domain invariant. And in our payment domain, well, a payment should have exactly one payment method. So what did we do wrong here? Let's look at our previous type definition, and we can see we had an implicit and, cash and credit card and PayPal. And if you remember how we described the type before, we used the word and, but in our actual domain, when we were talking about it in the text form, we used the word or. So how can we use the word or here as well? Well, unions give us the power of or, and this is not something specific to TypeScript. Many typed languages have this power of or, and TypeScript is one of them. So let's see what that looks like. Well, we have the old type payment on the left, and we have the new type on the right. And already this seems more reasonable to what we were talking about before with our text. This payment has two things, an amount and a payment method that can be one of three different payment methods, cash or credit card or PayPal. So it already matches the domain, the language that we're describing our domain. And another question is, well, if you were given each of these types, which one would be easier to understand our domain from? And if we have this new payment method type, we can see that we're not allowed to represent those bad data examples that we saw earlier. Over here, we see that TypeScript will say, hey, this is not a payment. And that's fantastic. We've encoded our domain in the code. So let's talk about something else called discriminated unions, which are the same as normal unions, except every single member of the union shares a common field. Well, what does that mean? And why do we care? Well, let's dive into each of these type definitions. We can see our cash payment has a method field, and the type of the method field isn't string, it's a specific string, cash. Similarly, we can see credit card payment has a method field with credit card string. And the PayPal payment method has PayPal. And you can see these are all in common. Every single type here, that's every single member of the payment method union, has a method field and has a specific string value. So why is this important and what does it give us? Well, what it gives us is the ability to switch on the payment method and then handle every single payment method individually. So cash payments are handled here, and then credit cards as well as PayPal. And the default case we're using in TypeScript to get us exhaustive checks. So what we're doing here is saying, hey, TypeScript, please tell us when we're missing a payment method here. And we'll talk more about why that's important later in the presentation. So let's dive into the credit card payment type again. And let's look at this specific field over here, last four. Well, last four is a string. And that's an infinite set, as Sam was mentioning earlier. We have the string muffin as a string, Cheshire and cat. Well, does it make sense to assign the string muffin to last four? Well, let's think about the set of the last four values. This is the last four numbers of your credit card number. Well, we want them to be 4-character strings where every single character is a digit. So can we say that this is the set of, can we make a new type to say this is the set of values we are allowing? Well, in TypeScript, we have this feature called template literal types. And what it gives us is the ability to do exactly that. The first step is we can define a type digit, which is the union of all numbers between 0 and 9. And then we can compose those digits into a last four type, where we have 4-character strings where every single character is going to be one of those digits. And then we can assign the last four type to the last four field. And what that gives us is the ability to have TypeScript tell us when we're assigning muffin to a last four and saying, hey, you know what? Muffin doesn't belong in the set of 4-character strings where every character is a number. So we're reducing the size of the set to make our domain easier to understand and make values that are not in our domain not representable. So one more point here is that we're going to strive for simple types. And I found that when people first learn about types, many of them reach for complex types in an effort to lock down the code. As a result, there are two outcomes worth pointing out. One, complex types don't lock down the code any more than simple types do. This is because there are always ways to avoid the guardrails set by the type system. And this goes for all languages. For example, we can always interop with JavaScript and lie about the types at the interop layer. And in TypeScript, we can also cast values to be of any type that we want. As we can see here, we're casting the muffin string to last for, which is not in the last for. Another outcome is that we're making it harder for teammates and ourselves to learn and evolve our domain because we've obscured it through complex types. So the goal isn't to lock down the code, but instead to create the simplest types that accurately describe the domain. And that's what we mean by solidifying the domain in code. But writing types is the easy part, and understanding the domain is the hard part. And for this, communication is key. And so why is communication key? Well, and this image is taken straight from domain-driven design. Every person that's working in a domain has a mental model of the domain in their heads. It might be right, it might be wrong, but everyone has this mental model. And in order to, as a technique to help everybody evolve their mental models, we want to use a shared ubiquitous language, which comes from domain-driven design, to help each other better evolve that domain. And you might be thinking like, hey, if we're constantly improving our mental models and we're constantly encoding, solidifying that mental model in code with types, doesn't that mean there's going to be quite a bit of changes in our code that might be expensive and dangerous and risky? Well, we definitely want to update the domain, update our types when we have a better understanding of the domain. But we're not afraid of this. And the reason why is we can fearlessly evolve the domain when we are encoding the domain in types. And so we saw this function earlier, this handle payment function, where we're switching on all the different payment methods. If we were to add a new payment method over here, we have Venmo as a new payment method, TypeScript would then tell us all the places in the code that we would need to go to update the code. So we don't have to keep any of these details of the code in our head. Simply, we change the types to reflect the domain accurately, and then TypeScript will tell us all the details as a result. So in summary, what does good domain modeling get us? Well, the code remembers domain invariants, so you don't have to keep them in your head. And as your domain evolves, the type checker will tell you what changes need to be made. And lastly, engineers can learn and even relearn the domain from a relatively small subset of the code, which is the type definitions, as needed. TypeScript Club is coming up in October, and if you're looking to dive more deeply into TypeScript or ask questions or dive deeper in the examples, let's please talk about it. Join the TypeScript Club channel, and the kickoff will be in October. Thank you so much, and thank you, Sam, for helping make this wonderful presentation.
Thank you, Raf.